Alright, welcome back. In this problem, we're asked to find the area that falls between the two functions x equals sine of 2y, 2 sine of 2y, and x equals 2 cosine y as y ranges between 0 and pi over 2. So I've gone ahead here and graphed my two functions here using Desmos, which is really nice for this kind of thing. And I can see here that my top function, the blue one, purple one here, there's my sine of 2y, and then the black one here is my cosine, 2 cosine. And so what I notice here is they cross right here at pi over 2. They also cross at another point right here. This point is actually pi over 6. I can get that right off the graph, or I could set those two functions equal to each other and set about solving it that way. But it's a lot quicker to do it graphically. And so we want to find the area that falls between the two. So we do notice that there's actually two regions. There's this region here, and then there's this region here, because we're going on the y-axis between 0 and pi over 2. And so what we need to notice is that the two functions do switch. So the sine function is the bigger function between pi over 6 and pi over 2, and the cosine function is the bigger one between 0 and pi over 6. Okay. So with that in mind, we can go ahead and set up our integrals now. So there's actually going to be two integrals because they do switch which one's on top. So we would begin with the integral from 0 to pi over 6, where the cosine is the big guy. So 2 cosine y minus 2 sine 2y dy, and then plus the integral from pi over 6 to pi over 2, where the sine is the big function. 2 sine 2y minus 2 cosine y dy. Okay. All right, and then we see what we need to have here to carry the substitution through, or to carry the integrals through. Cosine y, that's an easy integral to do. I don't need to do any adjustments to that. But the sine of 2y that shows up in both of those, I do need to make some adjustments for those. So doing my substitution, I can let, for that piece, u be 2y, and then du will call for a 2 dy, which fortunately in this problem, we actually have the stuff we need for that piece in both of those to carry the substitution through to change it over to u. Okay, so then we're kind of ready to do the integral. Okay, so integral of 2 cosine y. Cosine, again, behaves the opposite of sine. Sine when integrated is negative, so cosine will be positive. So integral of 2 cosine y will just be 2 sine y. Again, the substitution is ready to make that sine of u. Sine, when integrated, is negative, so that'll actually make it plus. Again, the 2 absorbed inside the dy. So it's sine of 2y, which is really sine of u. Integral of sine is negative cosine. I've taken care of the negative sign already. So this will be plus cosine of u, or cosine of 2y. It's evaluated between 0 and pi over 6. And then on the other one, the same thing. I have the 2 absorbed with the dy, so that's sine of u. Integral sine will be cosine, negative cosine. So this will be plus negative cosine of u, but u is 2y. And then minus the integral of 2 cosine y will be minus 2 sine y. And again, that's evaluated between pi over 6 and pi over 2. right, and then we go in and we start doing our computation. All right, so first off, we plug in pi over 6. Sine of pi over 6 is 1/2. 1/2 times 2 is 1. Plus cosine of 2y. 2 times pi over 6 is pi over 3. So cosine of pi over 3 is 1/2. And then we plug in 0. Plug in 0. So minus, plug in 0. Sine of 0 is 0. Cosine of 2 times 0 is cosine of 0, which is 1. So at this point I have 1/2, 1 plus 1/2 minus 1. And we move to the second piece here. Okay. So plugging in first pi over 2, cosine of twice pi over 2 would be cosine of pi. Cosine of pi is -1. So we'll put down 1. And sine of pi over 2 is 1. So minus 2. And then that's minus the second part, plugging in our pi over 6. Cosine of 2 times pi over 6 will be pi over 3. That'll be 1/2 with a negative in front. And then finally, sine of pi over 6 is 1/2 times 2. That would actually be minus 1. Right. And then we just have to go through and simplify our arithmetic here. So I'm going to have 1 plus 1/2 minus 1. That'll just be a 1/2. When I go into the second one here, I'm going to have 1 minus 2, which will be minus 1. But then the minus distributes to the minus 1, makes that plus 1. So all that stuff goes away, and we just have the negative distributed onto the 1/2. Makes it just plus 1/2. So it turns out, in the grand scheme of things, the area that we're looking at in this problem is 1. The area that we're looking at the problem here is 1. So that's what this region that we found here in blue, right here and here, turns out to have a total area of 1.